This video will take you through the memo for Section A of the Paper 2, the chemistry paper for June 2013. Let's start with question 1. First question, the reaction type that can be used to convert hydrocarbons with high molecular mass to hydrocarbons with low molecular mass. That is a cracking reaction, where a long carbon chain is cracked into two shorter carbon chains. It is an example of an elimination reaction, and we did accept elimination, but this is not a very good description of elimination. It's a much better description of a cracking reaction. Second question, a substance which speeds up the rate of a chemical reaction. That should be very easy. That's a catalyst. 1.3, the acid produced during the contact process. This really is one of those things you just need to learn. That's sulfuric acid is produced during the contact process. And finally 1.4, a gain of electrons during a chemical reaction. The little acronym OIL-REG, oxidation is lost and reduction is gained. So the correct answer there is reduction, and that should have given you your 4 marks for question 1. On to the multiple choice. First multiple choice question is an IUPAC naming question. And the first thing you do is you identify the longest continuous carbon chain. There it is. Don't be put off by the little kink in the chain. Each carbon is only bonded to one other carbon in a continuous chain, one on either side. So that's the longest chain, which means, well, sorry, before we go on to that, that chain has got 2 bromine atoms that are added as branches. And if we number the longest chain, we number it in such a way as to give the 2 bromine atoms the lowest number, so we'd start numbering from the right-hand side. Now you'll notice straight away that option B and D both have pentane as their longest chain, and we've seen that that can't be the, which means that B and D can't be the correct answers. So that leaves us with A and C. A is not correct because the 4 and 6, that would be if we numbered it from the other side, and that would give us higher numbers, and so the correct answer is 3,5 dibromo-octane. Right, question 2.2, boiling points of branched alkanes lower than straight chain alkanes of the same number of carbon atoms. What's the reason for that? Let's just have a look at some of the theory. If we take 2 butane molecules, then the intermolecular forces, the van der Waals forces there, are due to particular surface area, and there will be a certain number of forces which would give that a particular boiling point. If we looked at a branched chain of butane, something like methylpropane, you can see straight away that there are fewer intermolecular forces, and hence those forces are weaker because the surface area is less. So let's look at our options. The question says that it has this. These alkanes have the same number of carbon atoms, which means that option A and option D are eliminated, because if they've got the same number of carbon atoms, they'll have the same molecular mass and the same number of electrons. So A and D can't be options. Both B and C are possibilities, but option B is the better answer, because that gives the real reason, which has to do with the effective surface area. C is not incorrect. The branch chains do have shorter chain length, but the real factor here is the effective surface area. So B then is a correct answer. Right, 2.3, a reaction question. We're looking at the dehydration of butane-2-ol. During dehydration, the OH group will be removed or eliminated with one of the 2 hydrogens, either the one on the right or the one on the left. And so the question really is about trying to work out which of those will be eliminated. And if you remember, the rule says that the H will be lost from the carbon with the least number of hydrogens. The one on the left has got 2 hydrogens. The one on the carbon atom on the right of the OH group has got 3 hydrogens. And so that means that the hydrogen will be lost from the carbon atom to the left of the OH group. And so the double bond then will form between carbon 2 and 3. And that means that our correct answer is D. Right, 2.4 is a rates of reaction question. Option B, increasing the pressure on the system, we can immediately discount that because there is no gas as one of the reactants. We have an iron nail and we have hydrochloric acid. So pressure is not going to affect rate of reaction in this case. Adding a small volume of water will simply dilute the acid, which will decrease the rate of reaction. So that's not a sensible option either. The phrase there, completely covers the nail, means that the entire nail is already in contact with the acid. So adding more dilute hydrochloric acid, D, wouldn't be an option in this case. If the nail wasn't entirely covered, then that would have been a good option. So D won't be an option, which leaves us with A. And of course, A, by crushing the nail into powder, we're increasing the surface area of the iron nail. And you know that an increase in surface area increases rate of reaction. So at 2.4, the answer is A. 2.5, equilibrium question. When the equilibrium constant has a value much greater than 1, what does that indicate? Just remind ourselves that Kc is a ratio of concentration of products over concentration of reactants. So if Kc is greater than 1, it means that the concentration of the products at equilibrium is greater than the concentration of the reactants. So let's look at the options. C gives us that option, high concentration of products, giving us a Kc greater than 1. A is not correct. Kc doesn't tell us about how quickly equilibrium is reached. B, again, Kc doesn't say anything about rate, and D is obviously the opposite of C, so it can't be that. C is the correct answer. Alright, 2.6 about fertilizers. It's a relatively straightforward question, and if we just look at some of the key text here. You need a fertilizer to provide nutrients for rapid growth, and we're told that nitrogen does that, so we need nitrogen in our fertilizer, and protect the lawn during dry conditions, and potassium does that. So we're interested in a fertilizer that's high in nitrogen and high in potassium. Remember, the ratios are given for nitrogen to phosphorus to potassium. So we're looking for a high ratio of nitrogen and potassium, and option A gives us 8 parts nitrogen and 5 parts potassium with very little phosphorus. So A is the correct answer. Right, 2.7, this is an equilibrium and a Chatelier question. Let's go through each option that's given. The first one relating to temperature. Delta H for this reaction is given as less than 0, so that means the forward reaction is exothermic, and so the reverse reaction is endothermic. So if we increase the temperature, according to Le Chatelier, it will shift to decrease the temperature, therefore favour the endothermic reaction, which is the reverse reaction, and that won't maximize the yield of SO3. So number 1 is not a good option. Number 2, increasing the pressure. We need to look at number of moles. We've got 3 moles on the left and 2 moles on the right. So if we increase the pressure, Le Chatelier says it will shift to decrease the pressure, and so it will go to the side with fewer moles. That's the right, so it would favour the forward reaction, and that certainly would increase the yield of SO3. So 2 is a good option. Catalyst, it's not a good option. Catalysts don't impact yield, they simply impact rate. Option 4, increased concentration of O2. Le Chatelier says then shift to decrease O2, which would favour the forward reaction and make more SO3, so 4 is also a good option. So 2 and 4 are the correct conditions to maximise yield of SO3, and that's option A. So A is the correct answer. Alright, last one, 2.8. Redox question, which of the following statements is true about this reaction? Let's have a look. First one, Fe3 plus is oxidized. Let's go and have a look at Fe3 plus. Fe3 plus on the left goes to Fe2 plus on the right. So on the left it has an oxidation number of +3, on the right +2. And so the oxidation number has decreased, which means Fe3 plus has been reduced, which means that A is not correct. What about B? SN2 plus is the reducing agent. Now, SN2 plus is on the right hand side, so we would need to consider the reverse reaction. SN2 plus has an oxidation number of +2, and it goes to SN, which has an oxidation number of 0. So its oxidation number has decreased, so it's been reduced, which means it's the oxidizing agent. So SN2 plus is not the reducing agent, and so B is incorrect. What about C? SN gained electrons from Fe3+. If it gained electrons, then it would have been reduced itself, because reduction is gained. And if we have a look at SN, it goes from 0 to +2, which means that its oxidation number is increased, so it's been oxidized. So it hasn't been reduced, and so C can't be the correct answer. So it looks like D is the correct answer. Let's just have a look at it. SN is the reducing agent. If that's the case, then it's oxidized, which means its oxidation number increases, and we can see SN goes from 0 on the left to +2 on the right, which means that's a correct answer. So D is the correct answer for 2.8.